Hello and welcome to a new episode of Today You Learned. So in the last video of advanced sniffing, in the introduction actually, we learned about a tool called Responder, and now I want to show you a feature of that tool called Relay or Relaying. So in the last video we were able to capture NTLM hashes. So to go back into what is Responder. Responder is of course a tool that responds to broadcast or multicast packets going over the network, and then once it has an active communication or session with the victim, it tries to make them spit out their clear text credentials or hashes or challenges, and then we can crack that or reuse them or do something else with it, right? So the problem with newer systems like the ones that we have in our demonstration today, of course, is they will not use these older protocols that spit out clear text credentials or reusable NT hashes or whatever. They spit out, well, four types of hashes mostly. You have NTLM or net NTLM, V1, V2, and for each of these two versions that there are, you have the SSP option, which actually just means that there is more data, so SSP additions, secure providers that actually add details like timestamps and other stuff into the hash, but does not make it more secure, just more metadata that is being added. It is very important to note that these hashes or these challenges actually have nothing to do with local Windows hashes that we know are called LM or NTLM. It has nothing to do with those, right? So the problem with this, and that's actually the main issue here, is we cannot use those hashes to perform something called a pass the hash attack. We cannot replay, we cannot perform a re-authentication with these hashes. But what we can do is position ourselves with Responder in between two systems, or in other words, we perform something called a man-in-the-middle attack, right? And in the case of Responder, it's called a relay attack because we are actually relaying the different portions of the challenges back to our victim. So what we have is we have a server and a client. So in this case, the client is the one that we are actually interacting the most with. It's the one that sends out requests and we are responding to those requests. Then the client wants to perform an NT authentication, an NTLM V1 or V2 authentication with a real or with a victim, with a machine. And for the client, it doesn't really matter what that machine is. It just wants to authenticate. So what we will do with Responder or with the multi-relay attack or relay attack is actually we will tell him that we are part of the domain. We will perform all the normal authentication measures that we want to do, but we will actually replay the challenges that are coming from a victim server. So for this relay attack, we actually need two different machines. We need a client and a server. And we will use the authentication details from the clients to authenticate onto the server with the permissions that there are, whatever permissions they might be, coming from the client. There's one slight note. This requires that the feature SMB signing, which is one of the security features, more recent, more modern security features, needs to be inactive or disabled, which by the way is still today the default on any Windows client. Windows 11 up to date, the newest ones still have SMB signing disabled. Okay, that's the theoretical part. So what will I do? I will actually do the same demo in two different ways. First, Responder has a built-in tool called MultiRelay. The problem with this tool is that it only supports SMB v1 to perform a replay or a relay attack. So I will do this demo second after I have disabled or configured SMB v1. More details in the demo, of course. And then you have your framework, the framework called Impacket, which has an example script. It has a lot of scripts actually, and one of the example scripts is called NTLMRelay X, which is also a relay script. Very interesting because it actually has some exploits and other stuff in there. It's more than just a relay script or a relay tool. However, it supports SMB v2, and that's the main upside with the demo I wanted to do today. So I will actually start with this one. The difference is that the multi-relay tool built into Responder will give us a shell on the victim, if it's possible, of course, depends a little bit on the credentials captured, while NTLMRelay X will perform a sound dump on the victim, again, if it's allowed by the credentials captured or the permissions captured. One of the exploits, FYI, that is built into the NTLMRelay X script is a very famous exploit that actually bypasses the message integrity check, meaning that unpatched systems are vulnerable. It means that signing is not important anymore with this exploit. But it was a bug, so it was an exploit, which means it is now fixed, of course. So last portion here is that these tools, both NTLMRelay and MultiRelay, will actually run their own HTTP and SMB servers, so not to get any error messages, we should disable them in responder.conf. So without further ado, let's dive right in. So at the left side, once again, we have our victim environment. You have a first domain controller, a second domain controller, and a fully up-to-date Windows 11 with antivirus enabled and so on. All updates are installed until today. It's part of the domain demo 22. We are actually in the exact same network. This is the network. In the previous video, I scanned it as a hacker, so I was able to find the IP addresses for DC1. Then we have our Windows 11 and DC02. So for this relay attack, as you have seen in the slides, we need to have signing disabled, which is the only system that currently has signing disabled is actually the Windows 11. So what I will do is relay my attack and make this Windows 11 my victim or the server that I want to connect to. So I will try to capture other credentials, doesn't matter where they're coming from, or other authentication details, and I will relay them to try to get a shell on this environment. So I need two commands for that. I need a responder and a relay. So first I will have to configure responder to disable SMB and HTTP like this. Now I can actually already start responder. Exact same command as before, with the exception that we have now two disabled protocols, right, servers. Then right here, where I did my previous demo, I will now remove that once again, and we have a look at, let's start with the mPacket one, because these are all unpatched systems, patched systems, but with SMB v2 enabled. So let's first do this one. As you can see, I double tapped here. We can see that there are a lot of default scripts, example scripts from mPacket. But the one we need right now is this one. It has a lot of options. Actually, without any options, it's already doing stuff. I wanted to show you the help, just to show you that there are a lot of options, but most of them I will actually not use. I only need two options: the target, which is the IP address of the Windows 11, which should be this one, 50.90, right? Yeah, okay, 50.90. And the other option that we need is actually to specify the username, because it will throw out an error, I believe. No, I just need to specify username, because in a case you are in a production environment, you might not want to do this attack on every single type of user that is in the environment. But in this case, I just specify all so that I can use any user that we see. And apparently there was a typo of some kind. So, oh, no, this is actually for a different command. So the -u is not recognized because it's not necessary. The second command I needed, I was a bit confused, is to enable SMB2 support, which is by default not enabled, so the attack would not work. Okay, so we're ready. Now, to show you for the last time, actually, I will now be a victim of my own implementations, or a victim of my own commands, because I will now play the dumb user that wants to get access to a share. One of the ways to get access to a share is by just opening the Windows menu. Note I am logged in here into the domain, right? So this is actually a server that will now act as a client. What I want to access /connect to a share. As you can see, and this is actually what we are looking for, it says no results found for /, which means that Windows by default starts looking, scanning the network, discovering the network finding host names. I haven't typed any yet, so let's try that. So let's say I want to connect to file server. I start with typing the F because that's usually the first letter for file server. I type FI, L, and so on. And actually you can see that beginning with F, every single letter has already been requested by the Windows Server system. Once again, Windows Server 2022, newest system. And more than that, I haven't even pressed enter yet. I haven't done anything as a user. And right here, we already were able to dump the hashes of the local users of this Windows 11 system, right? It was able to wait for connections, to receive a connection from our Windows Server 2022. It was relayed to this one. This is actually the username, the user that I am currently logged in. It's a domain admin. That's why I was able to get access to the Windows 11 environment. And after getting access, it was able to dump the hashes. Once again, a fully updated and antivirus enabled system. So using these hashes, we actually were done with the attack. I can stop this and I can verify if these hashes actually do work. For example, on my Windows 11 system, which is this one, you can verify administrator. Let's try the administrator. The other hashes, as you can see here, are actually empty, but this one is not. So let's select it. Try to authenticate, and well, I have not specified a domain, so it has used demo22, and apparently this is not the hash for the domain administrator, which makes sense to have a local different domain. And in this case, it's a local user, which I specified with the D option, and we are now, well, accessed forever if you want, as long as they don't change the password for the administrator user for this Windows 11. Okay, that's part one of the demonstration. So what I will do now for the second one, actually responder can stay active if it wants. Let's take a look at that multi-relay option, but for that I need SMB v1. So to have SMB v1 enabled, let me show you two quick options to do that. Actually, SMB v1 is a lot of the times still enabled, even on newer systems, deliberately or not. So let's take a look at our Windows features. Need to be an administrator for that. So the only thing I have to do to enable SMB1 is have this checkbox. So as you can see, it says file sharing support for v1, which means that if this machine ever wants to communicate with an SMB v1 share somewhere in the network, or maybe a Linux SMB server, then this will probably be checked. So on systems that have been in use for a couple of weeks, or that are being used in a lot of environments, that SMB v1 is extremely often enabled. I have not found a lot of environments where SMB v1 is not enabled, right, where it's only SMB v2. I also need it here, so a different way and a quicker way actually to configure it is via command line, of course. Command line always better. You have a PowerShell command to just enable that SMB1 protocol. I could of course also do it via the software settings from this Windows Server. So while this is rebooting, and I believe the other one is already done rebooting, while this is rebooting, let me show you. I need to run this multi-relay tool from Responder from the actual folder where it is located, which is this one. As you can see, we have our multi-relay right here. Let's take a look at the help. This is a lot simpler than the other one, and here we will be using this one, this option. So I need to specify the target. And then we have our username. If I want to specify users to relay, I can do that, but in this case, let's just relay them all like this. Let's wait a little bit, and then let's verify. I just rebooted two machines, and as you can see, it's one after the other trying to do something on the network, and with a little bit of luck, we actually have other captured credentials or protocols. Remember, two of the protocols are actually disabled right now. So this seems to have booted now. Let's launch this. It has tried to communicate with the victim, which is our Windows 11, which identifies apparently as a Windows 10 Enterprise and so on. This is the host name, it's part of a domain. This is just a warning, not important. So since we have Responder running, and we have our multi-relay running. We can perform our attack again. So for the last time, I will actually do it manually, and in the next video, this portion will actually be done automatically. More on that later, of course. So //, let's take something else, blah blah. You can actually see it happening here. Let's see if something happens here as well. Yes, we have setting up an SMB relay. It has received a hash, it has relayed, I should say. And apparently DOM admin has admin rights on C#, so that's a share authenticating. And in this case, instead of performing a hash dump, which is actually still a possibility, we have a full command line environment. So if I were to type who am I, he will actually send this to the victim that we can see right here. Again, the victim that is fully up to date and has antivirus enabled. And we have a shell as system. What can we do with a shell as system besides the fun stuff, of course? We can, for example, do something like this, reg save, perform a manual reg dump. It's actually built in over here, but let's try to do it like this. And maybe for the fun, let's put it on the desktop of our user. I assume this is something like this, sam.hive. So this should probably scare him a little bit, seeing this file just pop up right there. You might also have noticed that I did not need to log in. This means that automatic login is enabled, and automatic login should be in the registry. Oh, well, before I do that, before I forget, I wanted to show you something else. We are NT authority system. However, our shell is actually running, so we have a running as David. So we can actually perform David right here. So we are not really logged into the environment as domain admin. I can actually prove that. If I perform a dir of the users folder, you will notice that the domain admin folder is not here. So we are not really logged in. We are just running commands as system who is running as David. It's a privilege escalation from David via the domain admin. Well, I would say hashes, but it's challenges, right? Okay, so now that we have that, let me run this one. So this will perform a register query of the WinLogon environment, where we will see the username that is used to automatically log on to Windows, in this case David. We can also see if there is a domain log configured. So David from the domain demo22.lan is the automatic login. And the last thing I wanted to show you is the default password for this user is actually 123. We already knew that from a previous demo, but now we have confirmed that there is a Windows domain Active Directory user called David, this domain with this password, which is a lot of fun. Okay, that's it for this demo. The next one will be even cooler. Thank you, and as always, keep learning.